This is the start of Project HA-2 in the HEC class at ITRE for the layout of Loop A. Step 1 says create a line offset 24 feet towards the bridge from the line you used in the previous project, the ramp project. This line should extend from NC 125 down to the edge between the shoulder and the travel lane for I-95. This line should be parallel to the line drawn for the ramp of on your previous project. So you can see Loop A is laid out here nice and neatly. Obviously you won't have any of this yet. You should at this point have the off-ramp drawn. So what I want to do is I'm going to zoom in. So we have the point that we've already marked for the off-ramp. Now measure 24 more feet down this center line of NC 125 and measure 24 feet and mark that point. Now from there what I would do is pick maybe the PT point here on your off-ramp and measure perpendicular to this, measure 24 feet and mark that point again. Then you have two dots to connect essentially. You can't do 24 feet from here because this is not perpendicular, this is not perpendicular. So I would pick a point not along the curve but along the straight section of the off-ramp and mark another point that's offset 24 feet perpendicular to that line, because then you can connect those two dots from the point you just marked on NC 125 to the other point and just continue in that trajectory down to the center line here. You can see I've drawn it to the center line. You can draw it to there. You can draw it to the edge of the lane line, whichever one you'd like. Either way, we're going to be working with this point here on the edge of the lane line more. But yeah, draw that line straight down. It should be parallel to the line that you drew for your tangent, the first line you drew for your off-ramp. Step 2 says where this line hits I-95 is the location of the PI for the spiral curve system, or the spiral curve spiral system. Determine the angle formed by this line and I-95. This is your overall delta for the spiral and should be equal to 180 minus the angle you measured for the ramp in the previous project. So just to simplify that as best I can, I'll zoom in. You can see again I've got this angle measured here, it's just 34 degrees. That was for the ramp project. Now this line here is the line we just drew for the loop ramp. So this point is the PI of the overall spiral curve spiral system for the loop ramp. So the angle I want to measure, you could either, if you drew this line all the way down to the center line, you can measure this angle in here, or what may be easier is if you just measure the opposite of the angle that we measured for ramp A. So we measured this inside acute angle for ramp A, so which means since these are parallel lines and this line is straight, then this angle should be equal to 130, or should be equal to 34 degrees. So the angle you want to measure is the angle from this line on the outside, the obtuse angle, to the edge of the lane line here. So it should be equal to 180 degrees minus this 34, whatever angle you found. It's not necessarily going to be 34. Whatever angle you found for the off-ramp, it's going to be 180 minus that angle, and that's going to provide you with your overall delta for this loop ramp. Step 3 says calculate T sub S, and T sub S is equal to R sub C plus P in parentheses, so add those together first, then multiply that by the tangent of delta over 2, then add K. So R sub C is already provided in your handout. Delta is what we just measured in step 2, so somewhere between 140, 150 degrees, something like that. P and K can be calculated from equations found in the book. So you're going to follow steps similar to what you see on page 58, which those values that you see there will be from page 57 in the book. Let's see if I can pull those up real quick. So Page 58 is here. This is just an example problem. So P is found by multiplying the length of spiral times this. All this is here, this step here is just an interpolation because of the theta S angle that they found. So yours, you won't have a theta S that's equal to an exact whole number. It won't be 22, 23, 24, 25, whatever. It's going to be 23 point something, 24 point something. So you will have to interpolate. So these values, this here, which is 0.001454, and then the 0.002909 are found in this table here. In that case, it was just for this 1 degree angle here. So there's your two values, 0.001454 and 0.002909. So you're interpolating between those values for this example problem, and then you multiply by the length of spiral. Now, this 0.875 is just the difference between 1 and 1.875, so you interpolated between 1 and 2 here. So that's all that is. You're going to follow those same steps. You're going to have different values. They're going to be slightly different, a little higher, I believe, because you're going to be working in the 20s for your theta. But follow those same steps, multiply by your length of spiral, and you'll get your P. Do the same thing for K. Those values you're going to plug in to your T sub S equation on this instruction sheet to find your T sub S. Step 4 says, starting at the PI and heading towards NC 125, move along the line you drew in step 2, a distance equal to T sub S. This is your ST point. So the line that you drew from this point that intersects here, the one that runs parallel to your off-ramp line that you drew for your ramp A project, that line here that runs up to NC 125, you're going to measure a distance from that point, the PI point, a distance of T sub S that you just calculated in step 3 up here, and you're going to mark that point. That is the ST, or the spiral to tangent point for your curve. So your curve actually runs maybe opposite of what you're expecting. The curve, essentially what we're saying, where it starts is at the bottom where it hits I-95 and then goes up to NC 125. So this spiral to tangent point is the end of the curve, essentially. You can actually see it marked here. This number is not the same as what you're going to get. This is a different number, but same idea. So it should be somewhere up in this area. Step 5 says, starting at the PI, move along I-95 a distance equal to T sub S. This is your TS point. Label this as the 0 station, so station 0 and 0, 0 for your ramp. So this is pretty self-explanatory, but I'm going to point it out real quickly. So from this PI point here, where it intersects this line, where it intersects the I-95 outside lane edge, measure a distance T sub S. You can actually see it faintly here. Measure along that outside lane line down here and mark that point. So your loop ramp is going to meet, the center line for the loop ramp is actually going to meet on the lane line, the outside lane line of I-95. So your center line of your loop ramp will not meet the center line of I-95. So mark that point. That's a distance T sub S from the PI of the curve. And this is your 0 station, and you want to label that when you get the chance. You may not want to label it immediately. You may want to wait to make sure you've got it drawn right and then label it. Step 6 says, find LT and ST, so long tangent and short tangent, for the spirals using Exhibit 7.4 and your given theta S. Move a distance away from the ST and away from the TS equal to the LT value and mark these points. These points can be thought of as the PIs of the individual spiral curves. So I'm going to go back to the notes again. If you're looking at page HA-58 here, You can see they've done a calculation for LT and ST. This is similar to what we just did with P and K. So you're going to be interpolating, because your theta S is not going to be a whole number. You're going to be interpolating between whatever values you see here for this LT and ST column here. So interpolate between those values appropriately based on what your theta S is, and find your LT and ST, your long tangent and your short tangent for the spiral curve system. And I'll go back to the drawing now. So move a distance away from the ST and away from the TS equal to the long tangent value and mark these points. So if you're looking at the TS station, so station 0, measure a distance along this tangent distance here, what you measured from the PI. So in other words, you're measuring along the line that goes to the PI. Again, you won't have this curve drawn in. You won't have anything drawn in yet. You'll just have a few points marked. So measure your long tangent distance along this outside lane line here. That's your, think of that as the PI for your individual spiral curves, because again, as I stated in class, a spiral curve works like this. You have a spiral that goes into a curve that goes back into a spiral. What we're finding right now with this step 6 is the PIs of those individual spiral curves essentially. So mark that point, then you'll come up here. Go from your ST station, also a distance equal to LT, but do it along this line that we drew, this faint line that you can see here that goes all the way down to the PI of the entire curve system. Draw it along that line. Don't try to guess which way the spiral curve is going to go or anything like that. Draw along that line, measure that distance, LT, and mark that point. Step 7 says calculate the delta sub C and the T values for the circular curve. So I want to really point out that this is not the overall curve system, including the spirals. This is not either. This isn't even the spiral curves that we just found the PIs for. This is just for the circular curve portion of the entire curve of the entire loop system. Calculate delta sub C. You can see on your handout, there's actually an equation provided for that that says your measured delta, so what we found at the start of this loop project, and minus 2 times theta S. We have theta S, we have the delta, so you can calculate that delta sub C. We're also provided in the handout R sub C. So when you're trying to think of what formula to use, what equation to use, if you go all the way back to page 36 in your notes, you can see this equation for T here. T equals R times the tangent of delta over 2. So essentially what we're looking for is R sub C times the tangent of delta sub C over 2. That's going to provide this T. If you want to think of it as T sub C, that's fine, but that's going to be the T value that we're looking for. So find delta sub C, you have R sub C, and then with those calculate your T. Step 8 says turn an angle equal to theta S from I-95 and then another one from the tangent of loop A drawn in step 1. Draw straight lines from each of the spiral PIs using the angles. These lines should intersect at some point, and each of the lines should be equal in length to the short tangent distance plus the tangent distance for the circular curve, which is the T we just found in step 7. So these angles are going to face the overall curve PI, and we're going to draw the lines using these angle measurements and extend them until they intersect one another. So I'm going to zoom out a little bit. Let's look first at this PI. I guess you can think of it as PI1 for the first spiral from station 0. So measure an angle that you have theta S. So I want you to measure an angle from this outside lane line edge here where you've been, the tangent that you've drawn from station 00 to the PI. Measure this angle in here and draw a line going in that direction. You don't have to draw it too far, but I mean you can extend it as far as you would like, but just at least get a line down there. And then do the exact same thing up here with this PI2, I guess you could say, for the second spiral of this curved system. So from the tangent distance that we drew at the very start of this loop project, measure theta s towards the PI, so opening up towards the PI, and measure or draw this line in. Again, kind of extend it as far as you like, but what you want in the end is you want the first line you drew from the first PI to the and then the line from the second PI. You want those to intersect one another. So draw them out as far as you'd like, but you want them to intersect, and you want to mark that point. Now, if you want to double check and make sure that that point is marked correctly, which is suggested before you get any farther, before you draw this in red or anything like that. Measure the distance from each of those PIs. So if we're measuring from this second PI up here, measure the distance from that point to this intersecting point. And what you should have is your short tangent distance that you've already found, plus the t distance that we just found in step 7. Add those together, and that should be equal to the distance, this line that you drew from this point, the second PI, to this intersecting point. Also, if you draw a line from the first PI to the intersecting point, you should have the short tangent distance plus the tangent distance of the circular curve. You'll actually notice on this on the loop curve that we have here that where your short tangent distance meets your short tangent distance, where that point is going to be where your loop ramp meets at, and again up here, but we'll get to that in just a minute. Step 9 says from the PI points for each spiral, move a distance along the lines drawn in step 8 equal to ST and mark these points. These are the SC and CS points, so what I was just saying. So if you measure a distance ST from this PI point down this line you've drawn, again, you won't have this curve in here yet, but measure along that line that you just drew, one of those intersecting lines, a distance of ST from the PI point, and mark that point. Come down here, do the same thing from the PI along this intersecting line, measure a distance ST and mark that point as well. These are going to be the spiral to curve and the curve to spiral stations. So you're going to go T sub S, which is the tangent to spiral station, then the spiral to curve station, because it goes into the circular curve with a constant radius, to the curve to spiral station, so it starts to spiral back out, and then it'll go to your spiral to tangent station. Step 10 says use your French curve or flexible curve to draw in your spiral curves as best you can. So we're not doing the entire curve system, we're just doing the spirals. I'll actually start at the start of the spiral curve system, so station 0. You're going to draw this part of the curve, so just the spiral from the TS station to the SC station. You're going to draw in that portion. You can see it's flatter here. A spiral curve has a constantly changing radius, so it's going to flatten out as you get closer to where the tangent is, and it's going to open up to more of a curve as you get closer to where the circular curve starts. So draw that spiral in, then come up here and do the exact same thing from the CS station to your ST station. Again, it's going to be flatter towards the ST station. It's going to open up some towards the CS station. So draw those in first, and we're about to do the circular curve. Step 11 says calculate E for the circular curve, and using that point and the SC and CS stations, draw in the circular portion of the ramp. So you already have the spirals, now we're drawing the circular portion of the ramp. This should complete your ramp. So essentially what you'll have is everything on this curve except for the curve drawn here from the CS to the SC or from the SC to the CS. So you're going to have the two spiral portions of that curve. And now we're going to draw this circular curve here. So you have this intersecting point. Measure the angle. The best way to do this after you've calculated the e-distance is measure the angle formed here between these two lines and then bisect that the same way we've done previously. And coming straight out from the middle of that, if you bisected that angle, mark a point, that distance E that you just calculated. So now you have 3 points to connect, so it makes it a little easier. It should look a little better instead of just guessing from the SC station to the CS station. So put your flexible curve down. This is going to be a constant radius, unlike the spiral curve. Put your curve down from the SC to the E to the CS station and draw in your curve, and that will complete your spiral curve system. Also be sure to compute the additional values requested for the loop portion of the assignment, and then you're done with the loop ramp part of HA-2.